Hi everyone, in this video I'm going to show you how to build the LabVIEW VI. At the bottom left here I have a summary of some of the old concepts that we used in Lab 2, and those two top ones are the main ones. Simulate signal, which you do not see currently but you will see a little bit later, and then acquire sound, which you see up here at the top left. Then supporting concepts were waveform graph, which we can see by double-clicking the item in the block diagram. That's a really helpful tool if you are not sure where something is on the front panel and you want to see it. If you just double-click, it'll highlight in the front panel. So that's our waveform graph, and then we have our merge of signals and our write to measurements block. Those are all concepts that we used in Lab 2 and hopefully you should be familiar with by now. The two new things that we're going to look at in Lab 3 are spectral measurements, which is this block right here, and then it leads to a graph which shows the results of that. Spectral measurements takes data from the time domain and puts it into the frequency domain, so it's a different way of looking at your data. And then the other concept is the filter. We'll see that right here, and there's a bunch of different settings you can change in that, but we'll look at that a little bit later. We'll start with a blank VI as usual. You'll see the block diagram on the left and the front panel on the right. Go ahead and right click, go down to Express, Input, and Simulate Signal. We'll worry about all of the numbers and settings later on, so right now just click OK. First thing we do is create a graph indicator, so you're going to hover over the output of sine and then right click and go down to Create Graph Indicator. It'll automatically wire that together and you can position that or resize it on the front panel as you wish. This represents the time domain of your data. Next we want to add the spectral measurements block, which will help us transition from the time domain into the frequency domain. Right click, go down to Express, Signal Analysis, and Spectral up at the top left. Here it's going to pop up with a dialog box. There are two changes that we need to make here. One is to select magnitude peak, and then the other is to select linear under result. So make sure you have those two changes and then click OK. Wire together from the output of your simulate signal block to the input of signals on the spectral measurements block. And then from the FFT peak output, right click and create graph indicator. Do the same thing with repositioning and moving that if you want to on the front panel. And another important thing is titling these graphs and changing the axis names so that they represent the data they're actually showing. Right now both of them say time on the x-axis, but only one of them is actually showing on the time domain, which is this one on the left. So we'll call this one time domain. And then the one on the right we'll call frequency domain. And then we have to change the x-axis to match that. So change time to frequency. Next we want to merge together the things that we want to save into a file for later analysis. For that we'll need the merger, so right click, down to Express, Signal Manipulation, and Merge Signals. This time we're only going to be using two inputs, so automatically it already has two and we don't need to expand it at all. The first one is going to be our raw data straight from the simulate signal block, goes into the first input, and then the second one comes from our spectral measurements. So that if we wanted to recreate both of these plots in, say, Excel or MATLAB, we could do that. And then our output we're going to wire to a write to measurements block, but first we need to create that block. Right click, down to Express, and then Output, and Write Measurements File. Again, there are a few things you need to change here. The first one is the location that your data will be going to. Make sure you know which folder it's being placed in so that you know where to look later on when you need your data. And then just give it a general name and LabVIEW, as long as you select this next setting, use next available file name, it will just add a number to the end of the name and not overwrite all of the files. So change the destination, use next available file name, and then one column per channel. And the reason we select this one is because if we did one column only for X values, then all of our X values would represent time. But if we look at our plots that we have, only one of them is based on time, the one on the left. The other one is in the frequency domain, and it's based on frequency, so its X values are frequency. And we see, once we collect data, we'll see that it has different X values than the time domain. So by selecting one column per channel, it's going to create X value columns, one for the time domain and one for the frequency domain. And then we hit OK. And now we can wire together our merge signals to the right to measurements. So we'll run this to see what it looks like. Let's go ahead and change some of these settings to settings that would be similar to lab. Again, check your handout to make sure you have all the correct values for the trials that you're doing. I'm just going to select some values here to demonstrate. So we have a sine wave at 125 Hertz, 1 volt amplitude with added noise. And if I run that, we'll see it's pretty hard to see the sine wave initially, but you can change the x-axis and zoom in to see it a bit easier. So now we see the sine wave, and then over on the frequency domain we see one main peak, and again you can change the x-axis. I would recommend doing this before you take the screenshot so you can see specifically where the peak is. And here it shows the peak at 125 Hertz, which makes sense because that's what we set our signal frequency to. When you run the LabVIEW VI each time, I would recommend checking your file location to make sure that it has deposited where you want it to. So we can go here and check to make sure, and then see that the last one was recorded at 12:20 p.m., which was the recent trial. This VI should cover the first few trials that you do, which would be 2 sine waves and then a square wave. After that, you'll need to switch over to using the acquire sound block. We'll delete the simulate signal block, and then right-click, go down to express, input, acquire sound. And here, the 2 important things are make sure that you select the correct microphone. I only have one, but if you have, say, a webcam or headphones, then I would recommend unplugging those and just using your laptop microphone. And then change number of channels to 1. Click OK. And now you can wire together this block and the rest of the VI. You'll also want to create controls for duration and sample rate. You'll do that by right-clicking on these 2 inputs and then create control. And you can reposition everything so that it's easier to see your block diagram. After you do this, you'll see 2 boxes show up on the front panel, and these are where you can control the duration and sample rate. After you do the first 2 trials of collecting an audio signal at a higher frequency and a lower frequency, you'll need to add a software filter. To do that, right-click, go to Express, Signal Analysis, and Filter. Here you'll want to change the filtering type to bandpass so that we can set both a low cutoff frequency and a high cutoff. Keep in mind that the numbers you use may be different, so make sure to go by the numbers shown in the handout. Then click OK once you change the cutoff frequencies, and then wire the raw signal from acquire sound into the signal input of filter. Now to see the results of this filtering, we have to create 2 more plots. The first one is going to be just a normal waveform graph by right-clicking on the filtered signal output, create, graph indicator. This correlates to our time domain graph of the unfiltered data, except this will be the same thing, but now filtered. I would recommend retitling these graphs so that you know which represents which stage of the data. So our top one will now be unfiltered time domain, and then the bottom one will be filtered time domain. We also have to create a second spectral measurements block so that our data, after being filtered, can be transformed from the time domain into the frequency domain, just like we did with our unfiltered data. Right-click, Express, Signal Analysis, and Spectral. Again, remember to select the two changes that you need to, being magnitude peak and linear, and then click OK. Connect from your filtered data to the input of this Spectral Measurements 2 block. Make sure that you're connecting the filtered data from here and not the raw data, because that's already being plotted on the unfiltered time domain and unfiltered frequency domain. We'll create a graph indicator for our filtered frequency domain, and then we'll retitle and change the x-axis for this one. This is going to be filtered frequency domain, and its x-axis will match by representing frequency. The top one becomes unfiltered frequency domain. This will help later on when you're looking at screenshots and you will recognize which plot represents which stage of the data. If you want to make this a little bit cleaner, you can right-click here and then go to Visible Items and deselect Plot Legend, and that will make that top part disappear. If you want to keep it, you can. It does tell you some information about the data. This one says sign with uniform noise, but that's also shown over here on the left. So it may be redundant to keep both. Since we've created these extra streams of data, we want to make sure that we're also saving the filtered data. Right now, our merge signals only includes 2 inputs, but we need to expand that to 4 so that we can put our filtered data coming out of filter, put that into the 3rd input, and then our frequency domain filtered data into the 4th input. After performing this software filtering, you'll need to remove this part that we added where it goes from the filter to the filtered time domain and filtered frequency domain. They won't be needed for the next module. So you can select them and delete, and then collapse the merger so that it only has 2 inputs. Now you'll record a hardware filtered audio, which was filtered by the TAs using a hardware filter that remotely you don't have access to. Then you'll be able to use this VI as is to collect the audio signals for 3 airplanes and the signal from a bottle whistle. If you have questions specifically about your lab, go ahead and reach out to your lab session TA. If you have other questions, feel free to reach out to me. Good luck!